Recording is in progress. Good morning, y'all. This is Platoon. Evenings, weekends, week 6, day 4. It's Saturday. I'm your host, Jordan. We're talking about Docker. There's a good little write-up here. You can read through it and get a good understanding of what's going on here. Or I can share a story. And by story, I mean this is a normal thing I've seen 100 times, and I'm very passionate about it. So I'm going to do that. You all can read this while you ignore me or read it later. One thing I've done for my job is review coding submissions. And it's not the simplest challenge in the world, but it's not bad. Um, it can be a little complicated. We get basically we put out, hey, here's the challenge, submit it in whatever language you're comfortable with, probably the language they're applying for, the team that they're using. But at our company, that could be Python, Ruby, Clojure, Swift, Go, Rust, Haskell, stinking C++, C Sharp, C Sharp, but .NET. I probably listed maybe like 80% of a few I'm missing. They just submit it and we had to run it. We wrote code to kind of run it that would make some guesses and try to run it automatically, but a lot of it had to be hand kind of ran. How do you do that? You look at code and you see if it's got a README, how to get it started, and you follow the README. Often, and when I say often, I mean it was almost the norm. We couldn't get code to run easily. We'd have to write up a custom script to get this code to run because someone would submit something, make some assumptions about our machines, about our environment, about the way we're set up that were not true. Basically, they would say, oh, yeah, just run it this way. And I would run it and I'd get some kind of error that says, no, you don't have that GCC version to run CPP, your whatever, mentioning the library that was failing and all these different versions. And no, you don't have the right CMake matched up for all this. And that's like, okay, well, I'm not doing all that. Fail. And you pass it on. Uh, if I really loved that candidate and they just nailed the interview and I really was interested, maybe I would go through and do all, try to figure out what the heck's going on, try to unbug their code. I don't know if their submission ran. I don't know, if it was correct. I just know it never made it past us. And this happened probably 50% of the time. Uh, when you're writing your code, it's important to share it, I think, with others. It's important to run it in other environments. We get out stickers at work that say it works on my machine because people, it works on my machine. It's like, oh, great. Who cares? Are we going to run it on your machine? Is Google running on some dude's, like PC he's got up in his room? It's like, no, he's gotta go somewhere else. Who cares if it runs on your machine? It needs to run somewhere else. There's a lot of little things you can do to make that easier. One big way is to make sure everyone uses the same machines, everyone uses the same computers. We all get Macs. It's going to be deployed on the Linux, but that's, it's easy peasy. We're at least all deploying to the same place. But even that, you can have some issues. You don't know what what version of Linux they're running. You don't know whether your version of Mac OS is caused some weird change to the way Python interacts or the way some baseline Linux commands work. How the heck do we do this? It's a very difficult problem. It's a very painful problem to always make sure that someone else's machine is the exact same as yours, not to mention just the versions of the software you want to talk about. Talk about like low level stuff. We can use containers. We can use Docker. Docker scratches this itch. It does a lot of things, but the main problem it's trying to solve is these are all the instructions you need to run my code. Like, no, screw that. Why don't you build a Docker file that could, I don't know, go online and find the image of an Ubuntu machine. Like it'll just like, this is a snapshot. This is what a virtual machine looks like. If it was Ubuntu, this version, whatnot. It needs these things. All right, well, I'm going to put a list to install it, install the things I need. And then I'm going to put in a command to run what I want it to run. So you don't have to do anything. You just have to say, run this, or, Docker run, and it's going to do exactly what it needs to. I don't care what your machine is. I don't care what your machine has. As long as it has Docker on it, it's going to run this, right? It could be a Windows image, and you pull it down on your Mac, and it should run. Sometimes it's not a perfect system, but it works well. What Docker does is it takes, I talked about this image, I'm using words like image and stuff. It makes a container. The containerization is what Docker's all about, is everything you need for that specific task. There could be a lot of containers within one like Docker image, the image being the full blown thing. The image would be the version of the OS you're pulling in, all of the dependencies, and then the code itself. That's all included in the image. But there could be multiple little containers doing little specific tasks in that image. I know I'm using a lot of words that we may already hear for the first time. Some of this stuff just needs to kind of be played with a little bit to make that stick. But we like to talk about Docker early. Full-time course teaches Docker later. We're going to change that when we merge these curriculums, because I think you should learn Docker as soon as you can. It is not a complicated, weird thing for advanced developers. Just because the things that I've described to you are problems you don't think you've had to deal with, let's just get used to doing it, right? Because I don't want you submitting a coding challenge or whatever, submitting code that other people can't run, right? Wouldn't it, just think about how that elevates you as a junior developer, being able to package all your code up and just say, here you go, just run this. Rather than, here's my repo, I got some instructions, just make sure you match all these things, and I sure hope my README is good and it's not 15 lines, and I sure hope you follow all the instructions exactly perfectly, and I didn't make any mistakes, and if I make a mistake, I have to update it in the README. Good luck running my code. Like, nah. We're gonna do something else. So again, a lot of this sounds very abstract, maybe complicated, but we're just going to talk about what's going on here. I talked about Docker, a Docker file. Truly and honestly, step one, installing Docker on your machine. I actually did this morning. Turns out I hadn't put Docker. This is a newer Mac. Installing is quite easy. Install Docker Mac. For all your Windows and WSL needs, I could work with you on that after this, but at least I'm going to show you how this should happen on a Mac, which I think most of us are using. I go to Mac, Docker Ducks is the first thing I popped up. Google, there it is, Docker Ducks, easy peasy. Docker Desktop from Mac, Apple Silicon, I clicked that, it downloaded, opens a DMG. From there, I drag it to applications. You follow the start. I don't think I'm going to be able to do this. I didn't want to uninstall Docker to show you all this. But basically, it's this kind of thing, right? You drag and drop on over there, then run it. It's going to boot up Docker desktop, which looks like this. Once you sign in, you don't have to pay for it unless you're like got a big company or something. They just be regular personal use. Follow their like 3 prompts of like, are you a student? Are you an instructor? Are you a coder for fun? Do those, get Docker Desktop running for you. And here's the kicker for Mac. This application needs to be running for Docker to run on your terminal. It's one of the limitations, I would say, of Mac. Although this works amazing, sometimes you don't always have a screen, right? Sometimes I'm working on remote machines and I don't want to run this junk. But for our class, it'll be fine. I'm not going to show y'all Docker Kalima. It's a pain to set up. However, this works really easily on Linux. So y'all can install that in the background, whatever. You'll need it for the assignment, but let's keep going. I just want to show how it doesn't take too long to get this all set up. Should WinUser install for WSL or Hyper-V? Probably WSL is what I'm gonna say. So what I'm gonna say. But man, I feel like Homer uses Hyper-V. Let's try it with WSL.
All right. Do you want me to test? Because I know a little bit about it, but
Absolutely.
all right.
Okay, so I've opened up here we are in the curriculum, module 1, week 6, day 4. We got Python app, we got a README, looks great, all these things. But what's this Docker file here? And by the way, the problem we're trying to solve is this is written in Python 2.7. Y'all better don't be writing in Python 2.7, okay? I like two things about the syntax. Other than that, needs to die. Should have died a while ago.
Jordan, is the
Yes,
is the Docker that we installed for the visual code, is that enough, or do we actually need to install the Docker desktop app?
you're talking about a plugin that is going to help your IDE notice Docker things. It still needs to be running on your application.
Okay, all right.
Unless
Thank
I'm way off, unless I'm way off about the plugin and it does more than that, but I don't think it does. I think it simulates some Docker things
Okay,
or
thank
it
you.
helps with it. Yep. Here's a Docker file. Let's look at this. 4 lines. Here's my thing. Full-time thinks you guys ain't smart enough to figure this out. We got to show you later in the court. I think you can figure it out now. I don't think this abstracts squat out because you all know to get to run Python, you type Python in the Python file, right? We all know that. We're just going to move it here, not have to do that again. So line 1, from Python 2. The hell is that? That's telling us that it's going to go to Docker, Docker Hub, the place where Docker has a bunch of sweet images. I don't want that open anymore. And it's going to find a Python image, a Python 2 image. It's going to default to 2.7. It's the latest, greatest, the only one left. So it's going to go to Docker Hub, find Python, a Python image. All it is just an image of Python with 2, Python 2, and whatever bare necessities it needs to run Python. Working directory is saying, hey, this is the working directory within the app. So when I go spin this up, I need you to look, or rather, this is on the container where you're going to put it. You're going to put it at /user/source/app. So take this, install it, make an image of it. This is where I want you to put the next things I'm telling you. What are we going to do? We're going to copy this file and put it right there. Simple file, right? Easy peasy. What's up with this syntax, Jordan? That's Python 2.7. I love that. I think this is great. That's like how Ruby does it. You wanted this Ruby. That's how you do it in Ruby. I dig it, but it messes you up. Can't do this in Python no more. So we're all on the same page. This is what we're missing. In case you didn't see it, right? Like that's how you have to do it in Python 3, not Python 2.7. And my machine's throwing a flag right now because I don't have Python 2.7. So go to Docker Hub, get a Python 2 version, set it in this working directory in this container you're about to build. What's going to go in that directory? This file. It's located right here. Notice Docker file here. There's this file. So it knows exactly where it's at, saying, hey, where I'm at, go get this file, slap it in the work directory. What are you going to do with it? Run this command. This command here in this order, right? Type the word Python, space, then type these. We can get more complex with these commands, but this is a fairly straightforward way to do it. Okay, I've talked through all this. Make sure I didn't miss anything worth chatting about. That all is what I said, right? Okay. So, like I talked about, all this comes from hub.docker.com. I don't want to click on that. It's free. It's not like going to charge you or nothing. It is for, you have to have like 200 employees or something before you got to pay for it or make some kind of money. All right, so here is the actual. Is this going to take me right there? I forgot to click this link. Yes. Yeah, I need to fix that. This is the Python version we're getting from Docker Hub. This is Python. It's version 2.7. This is what we're actually going to go get. If you go looking for it on Docker Hub, this is it. If we visit the official Docker or Python Docker imagery, blah, 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 counter embarrassment of images, yada, yada. Python 2 is not to be used anymore, y'all. Great. But to do that, to build that image, we do need to Docker log in. I think mine's going to just error out, maybe because I've already done this, or it's going to let me log in again. Okay, so this all works because I put in I made an account. Actually, I already had an account, but I made an account with Docker Hub. All this is doing is authenticating to Docker Hub. Now I can go to Docker Hub, which I don't even really want to visit. I want to keep this kind of just believe it's there for right now. We're not going to go look for images. And we're just going to run this or build it rather. So here's the command, and I'm going to just copy paste it, talk about it. Where are we at right now? ls. Oh, I need to get into our Python app. There we are. I'm at this level. Did I do my FizzBuzz solution there? That's not supposed to be in there. All right, so Docker build. We're going to tag it as Python says hi, and we're going to build right here. What does this dot mean? Well, Docker build is saying, hey, build a Docker image. We're going to use the Docker file right here. I just have to point that at some Docker file. Keep in mind, there's one here. So it's going to find it. You don't have to say what a Docker file is. It's looking for that name. We are tagging it, and we'll see the tag here in a second. Python says hi. Let's go. Whoa, look at all that. All right, since I already built this earlier, this ran a little bit faster because it's cached some of these things. But this is what it's doing. A bunch of hoopla that we don't necessarily need to super understand until there's an issue. But effectively, what did mine do? We went to Docker IO library, Python 2. This is the Python version image we pulled down. We brought it in. I cached this working directory that I said I was going to. I copied that file to it. And now it's basically, yeah, it's built the image, right? Can we see that yet?
That image is on Docker Hub under your account?
This image, I believe, is only local. Where's my container? Did I even spin it up yet? There we are. Hey-o! Here's my image. Created 54 seconds ago. 1.25 gigs. Holy jeez. So it's at least here. What do we do with that? Well, let's look at it. So I showed you here on the desktop. I want to show you Docker image. Oh, that's the wrong command, Jordan. Images. Y'all will see me make some weird mistakes with syntax here. Docker and Kubernetes run together a little bit. Not for that, but for later. Here it is. They call it this repository here is tagged Python says hi. Tag is latest. We'll talk about that some other time. Here's an image ID, whatever. We don't need that right now. A minute ago, that's the size. So that's it. It has created an image snapshot, a memory of Python 2 with my file, i.py, loaded up in it. And it exists. But it's just sitting there. We can now run it if we would like. This is local. It's just sitting here, an image, all this stuff. Python version, file, and the command to run it. It's all packed in there and it's just waiting. It's not doing anything. It's sitting here locally. Docker run Python says hi. I'm just gonna Docker run, and then I'm gonna give it the image. Heyo! Seems like a lot of hoopla. I could have just ran Python on my machine, right? Well, no. Remember, this is Python 2. I don't have Python 2 on my machine. You probably don't either, unless you got like a, you might, but you probably don't. The difference between just sending you my file and saying run it is that I've given you everything you need to know or do. As long as you have Docker and you've pulled this image down, which by the way, I can push this image somewhere, right? Just like you've got a repo in GitHub, I can take this image and go slap it up on old Docker Hub. You can then go find mine or wherever we're putting this, whatever repository we choose to put this, doesn't matter, it's arbitrary. I could go put this on GitHub, maybe. I don't know how they like images, probably not. It doesn't matter. I can put this image somewhere. All you need to do is pull my image down, make sure Docker's running for you, and then just Docker run my image. You don't need to install anything else. You don't need to download anything else. You don't need to read squat. You just run it. And it runs with everything it's needed that I decided, that I wanted to have it to run. That sure seems like a lot of overhead to print 2 words, yada, yada, yada. It's not. I can see it in your eyes. Trust me, this is cool. There's a bunch of different ways to kind of run this. And a lot of this is ephemeral, kind of, it happened and it's gone. What happened to your image, Jordan? What happened to that container you built? It stood it up, ran that, killed it. Because I didn't tell it to keep running. It did its job and then it died. It's like Mr. Meeseeks. I don't know if I want to quote Rick and Morty, but it's like that. Maybe that sticks out to some of y'all. It goes away when it's done. What if well, actually, I'm pretty sure it's still running, maybe, but it's just not like doing anything else. There's nothing else for it to do. If I wanted to get in there, I could. We can look at these commands specifically, but trust me on this. Run-it is going to let me exec into this, like SSH into it, like remote into this image that I've stood up. And at the end, I need to put the word bash so it knows how I want to interact with it. Again, we're going into some random image. Who knows what's on there? I need to at least tell it how I want to interact with it. Ooh, this is ugly. What's going on here? Well, that should look familiar, right? Where are we at? Oh, well, okay. It doesn't 1 for 1. But I am root user within this container. Look where I'm at. User, source, app. That looks familiar. That's the working directory. That's the entry point to my application. That's where all this stuff goes. And what's here? Hi.py. I'm in the image now. It's alive. It's a real thing. It's not, it's like a pretend Python environment all sitting here by itself. I'm not in my machine anymore. Anything on my computer, this is agnostic of that computer. This is its own thing. I just built, if you want to think about it this way, another computer, and I set it over here. Now we're hopping into that computer. Ignore everything I've got. We're in a new, brand new, spanking, fresh whammadime environment, and this is all it's got. This is all it knows.
You can create a new file right now, and it would create a new file in that image.
Yeah, there it is. Is this where? I don't know what the base of this is. Yeah, I didn't think so. I don't really want to fuss with that. But oh, check that out. There's our Python. So if I want to Python, hi there. We're in it, right? It's not some weird thing that exists that we can't see, we can't interact with, and it just runs. And Jordan said to set it up this way, and I guess it runs my code. No, this image sitting locally, we went into it, we're interacting with it. I know I'm beating this down a little bit, but this is some new ideas. It's not very complicated, but it is new, fresh things you've never heard before. So feel free to ask a question at any time, even though I'm making it seem maybe easy.
So I'm trying to like conceptualize this as like how would we use it in a website development environment? So if we had a repo that all of our files for our website were on, and we're worried about something falling behind in history in terms of like updating libraries and stuff, could we Dockerize whatever that portion is and then call upon it within the library or within the repo?
So you would send your image to whatever server or service is running it. It would spin up the Docker image and with some pointers or whatnot, point a URL with some DNS to your image, right? It's still on the server. It's running the image there, but it's running your image. If you wanted to make a change to that image, you would simply push up a new version somewhere. What doesn't matter again. You tell the server that's running your Docker service, hey, pull a new one in. Trash that one, pull a new one in. You could go into the image and update it manually, but that sucks. Just put up a different container. Send the new, better image. Just you're gonna have a version history of completed products with everything you need. It's like a whole new cloned version. If you were to git clone it, you're just got stop that. Dadgum, y'all see that? I made a square zoom. This is a square. You would deploy a new image with everything you need in it, right? You're not going to get on that. This thing I'm doing right here, this is for troubleshooting. We don't need to be hopping into this image for nothing, really. I'm just showing you that it's here and we can interact with it if we need to. And that can be helpful, right? Having to spin it up and run it every time, sometimes that abstracts out the problem a little bit too much. Sometimes you just need to hop on and work with it. But if you were deploying this, you would be using some service that Docker runs it and then points traffic at it. And if you wanted to update it, you would simply pull in a different version that you fixed up, and it's still going to keep doing that, pointing at this new Docker container.
So essentially all your
Everything-
website files would be in the Docker. You
Yes.
wouldn't have like your own like repo and GitHub, and then it would like reach out because you're worried about a certain section within your website. But I'm just using website as like an example.
So both. You've got your repository with your code. You pull that repository down, you make changes to it, whatever have you, keep it in version control. But when you're ready, your deployment path is going to say, hey, this repo, I've made changes to it, it's ready to go. Docker, build that bad boy, send it up. You're just taking a snap. I don't like using the word snapshot. Snapshot means different things in this field, but you're just snapshotting a version of that repo into this image, packed in with everything else you need, and that goes somewhere else.
Everything
And
else you
that
need
can
as
be
in dependencies.
everything, all
Okay.
dependencies, even the machine itself, like your Linux machine, everything.
And that makes it so it works on everyone's computer because it has everything
Yeah,
at that
if
time in
you-
history where it worked on everyone's computer.
Right. Like if you built something in Windows and it had very specific versions that are available on certain, oh, by the way, I've used my Windows 2012 server and I need only the library only works on that. Fine. If there's an image for it, slap it all in here. I can pull it down on my brand spanking new Mac and it should run just fine because you gave me everything I need. I don't have to think about it. You don't have to think about it. You just say, run that, pull it down, run it, you'll be good. In theory, it sometimes doesn't work so well between OSs, but don't worry about that so much right now. It's very rare. Just because I'm a completionist. Docker, run, help. Jordan, what does IT mean? I don't know. Top of my head, who cares? Interactive. Oh, we're going to open up an interactive shell using sudo tty. Doesn't, God, what does tty mean again? We got over here. We're execing into this bad boy, and then we're providing it bash at the end. Notice if I look at the help for this, it's probably going to tell me how to invoke it. This is fine. Oh, there we go. Docker run options image command arg. What the command is I want to run when I get in there. I typed bash at the end because I want to use bash to open up a terminal. As you saw, that's got Python version, that version. That's not my Python version, right? I'm outside of it now. I'm back on my own computer. Notice Jordan West at Jordan's Mac Mini. That's not Python 2. I don't have Python 2. I can't find it. Doesn't exist here. Oh, yeah, okay. That's what I was kind of looking for. Let's get back in there real quick. Cat Etsy OS release. Cat is, hey, just read this file basically. And Etsy OS release is going to be what this image actually is. So that was a Debian new Linux 10 Buster super sweet image, right? Notice none of these things say Jordan's Mac Mini. This is a different, this is a whole image we stood up. This is a different machine. That image is running this Debian new Linux 10, right? Codename Buster. Yeah, we did run our dang file. So you can detach these things in the background. Let me kind of explain what that actually looks like though. So this is basically, if you want to run something and just let it go, you need to detach from it. Otherwise, it'll run and shut itself off when it's done. If we want it to keep going, stay alive, not spin it up every time, but just keep it going, we can detach from it. Notice this is the exact same command I did earlier, just got a -D in it. Like I said, this thing, I said it's still alive and running. It's not really doing anything if I'm not running it. It's just alive and available on my machine. When I run it and get into it, it spins it up and starts up. But the difference with this is it's going to continue to run on its own. It is actively running. Oh, I got ahead. How you know it's really running? Docker has a command for that too. I wanted to show it not running. I'll do that in just a second. Docker PS. What's PS mean? What's up my head? Process status. There we go. That can mean a lot of things on different machines. Don't get too worried about this, but you can look up everything running on my machine with some PS commands. Docker PS is just easy peasy. Hey, what's going on with Docker? This image. I want to see all the containers. This is what's going on. These are old ones I have not killed off, I suppose. How do we stop it? You can give it the name, or you can give it the container ID. Sometimes the name doesn't quite work out the way you want. So we got a lot of different image names. My preferred way to do this, so I'm not confused about what I'm doing. I just take the container ID, Docker stopped, Docker PS, about a minute. No, that should be dead. Hold on a sec. Oh, you can just give it the first 2 or 3 letters. Why did it stop, y'all? Should have killed it. Is it not actively running? Oh, I'm confusing myself now. Oh, these other ones are running. Oh, because I did tat.
Jordan,
Yes.
so I heard you mention remote downloading. So all of this stuff that we're seeing, this is all local to your machine as far as the Docker images. Um, what size are these images? Like, I mean, I know it'll be, based on the amount that we put in, but I was just thinking like, we that a person has to be careful on how much they keep. Like, I don't know if it's a real big image or if it's a compressed image.
This
1 gig.
is this is 1.25, and this ain't a big one. But you're on the right path, man. Some of these get gigantic and they shouldn't. There are a lot of ways. We're not going to dig into it right now. That's more DevOpsy. There's a lot of little things you can do to really keep these images smaller. There's like bad habits. Basically, you pull in way more than you need, or you run a bunch of extraneous stuff, or you make it do updates that it doesn't need once it starts up, makes it slow, makes it take a long time. There's a lot of ways to trim this down to the bare minimum to keep
Okay.
these sizes smaller. Good thinking ahead. Right now, we're not too worried about that.
Okay. Thank you.
Yep. So the reason I still had one running is I didn't stop the one that I'd actually detached. Okay. So you can create a Docker image from scratch, use Docker file, and then run a container. All right, okay, so I'm gonna prove to you that this was actually running 2.7, which I don't really see a lot of benefit in that. Well, let's do it anyways. Because I feel like we already proved it. So Docker run, detach this, leave it running in bash. Was I not supposed to get in there? Then we copy our file into the directory we designated the container. Docker CP. So that's running now. This image is running, it's alive, here it is. See there? I'm gonna copy a file into that image now. I don't know if I have to, okay. Let's just run that. Am I in the right spot? Ooh, that's because that's not what its name is, Jordan. There's my container name. So if I want to copy into the container, I can Docker copy file, but then I need to specify the actual container. The actual container is this bad boy right here. I bet the container ID works. Don't want to feel silly if it doesn't. There we go. So I copied that 2 KB file into this running container. So it's still running, it's attached, it's just sitting there doing its thing. It should have that file now there. So we can Docker exec into it. Oh, I did it again, didn't I? I know this looks like a lot of hoopla. That's just the name of the container. Okay, we're in it. What do we got? Oh, hey, there's that file I copied into here. We're just displaying that I can copy things into an active running container. This isn't going to be a very common thing you do, but this is a thing you can do. That container is still running. It's still there. It's a thing I can interact with. You've seen me hop on there. You've seen me create files. This is nothing new. I'm just adding a file to it. All right. Yep. We see under file. Yep. So again, this file is here. Hi, but in Python 3, what does that look like? Oh, Python version equals 3. So notice this. Again, this is ugly. Do we have VI on here? I would be hyped if we do. Yeah, it doesn't have him. But just so we know what that file is, it looks like this. Notice format strings in Python 3. 3.6 edition, in fact, couldn't do this in 3.5. Probably won't work. Python. Hi. Oh, no, it don't work. Python 3. Ooh, Python 3 on this image. But it also has Python 2 on it. So this image comes standard with Python 3. But what was set in the environment is Python 2. This is built in Python 2. That's why it knows what Python is. What did I kind of want to also, just a thing to kind of recognize. Notice this has got these files in here. The one I originally stood it up with, hi.py, is here because of my Docker file. Hi in 3.py is because I copied it in there. We can create whatever we want. Temp file.txt, echo, Jordan password equals, whatever, into, secret.txt. Check it out. I've got a secret file on here. I've added it. I'm interacting with this image, doing all kinds of naughty things on this image, whatever I want to do. That image is still running, right? I didn't tell it to stop. It's right here. But if I were to kill it, it is killed. It's done. That image just stops. Everything we were doing, that's dead. See, no more container running. If I wanted to start that up again, oopsies, Docker run. All right, we're spinning it back up. It's brand new. Let's go check it out. Oopsies. I messed that up. Okay, well, that's fine. We'll just. Take the container ID. Okay, we're back in here. We're in the container. Remember, I stood one up. I added all kinds of crazy stuff to it. I had some files to it. We interacted with it. We did some work on it, and then I destroyed it. I'm running this image again, saying, hey, look locally. Look at this image that I built from this Docker file here. Spin it up again and run it. What files do you think are going to exist on this container? I killed the last one and I'm running it again. I'm running this image. What's going to be on this file? Or sorry, what files are going to be on this this directory, gang?
You didn't build a new one, so should it just be the original hi.py file?
Bingo. Because I ran not that old image, not that one that I hopped into, played with it, copied things to it, and messed around in. That was fine. That was kept alive, but I stopped that. I ran Docker stop, take that down, that image is gone. Docker run is going to take that snapshot, that original image from this Docker file, and it's going to run it. Those files don't exist in this Docker file. I only see one file here. That's the only thing it's going to be on. This is going to be an easy replicatable thing. And isn't that great though? Because now like I'm futzing with this and messing with it. And you can pull it and you can mess with it and work on it. And anything you don't want, like let's say I added all those files and did all this stuff. But maybe I didn't really want all that. Maybe I really only wanted like, just this other one, right? I need to add that to my Docker file because otherwise it's not gonna end up in that final image that I end up publishing.
And then you need to run the build command if you want to update the Docker file, right, to change it.
Oops. And then we'd push it to its new place. That comes later. For now, we have to get our heads around this idea of these containers just spinning on my machine. They are self-contained computers. If you want to think about it that way, it's like arguably correct, but it is a way to think about it. I've started up a little computer, an image of a computer, a container, and it's doing just these things I asked it to. It's alive when I run it. When I run it and keep it alive, it is a live thing sitting there chugging away, burning my 0% of my CPU. But if it was doing more work, it would be doing more. And that's phenomenal because you're going to get the exact same thing if you were to pull down my Docker image. It's going to do the same stuff. I wanted to update it. I build a new one, Docker build, Docker push. It goes out, and now it's got all my updated code, everything I need in it. If I, if I make some changes and I'm like, oh crud, this Buster, image ain't all it's cracked up to be. I need some more stuff. Maybe I use a different image. Maybe I would install some stuff or add some steps to install more things, you know? Like I might do something like run, npm install React. I doubt, we do something like that. But if I needed React on this image, I would do something like this, and it would install it. This is not good behavior. There's probably better ways to do this, but just showing you, like, I don't need you to do anything to run my Docker image. I'm going to put it all here, and it's just going to run the way I intend it to, and you can interact with it directly. This is more for deployments than it is necessarily like a development kind of point. When you're doing development, a lot of that's going to be from your repo, like we've been doing. The only difference is instead of just running a file, let's go the extra 2 steps. And by the way, I mean, it's not like, oh my God, every time I test my code, I have to build a new image and I have to do all this and I have to run it. It's like, no, just put it here. We don't need to do anything else. And this is going to be helpful later because some of our commands are going to be like, Django, admin, run, project, whatever, with files. Like we're going to get like these really, really long commands, or we're going to have multi-step commands. Like, hey, every time I need to run something, I need to blow my database away. So I need to, T-SQL drop database, Jordan DB, and then T-SQL create database, Jordan DB. Okay, I ran those, great. Now I need to Django make migrations, and then Django migrate. Okay, now Django run server, which is not even the full command. Or actually it's something like this. Right? So every single time I want to start up my whole Django environment, I got to run all this crap. Are you kidding me? Nah, man. We'll just like put it in here, right? Except that's not going to paste nicely. But we only have to do it once. If I want this to kill the database, create a new database, make migrations, migrate to the database, and start it up each time in my container, I just do everything that I normally have to do, and I just slap it in this bad boy. We're already saving time with that. This is just scripting, though. I mean, you could just take all these and slap them in a text file, but that ain't what y'all do. Y'all like to do this. Every dadgum time, no one ever hits tab in this class. Moving it in a Docker file like this can really, really speed up your development time, your deployment time. And if we're doing it from the beginning, y'all, at the end, once you've created this massive, beautiful project, you're not going to be sitting there sweating it out like, oh, how do I get all this into a Docker file? I had to install like 17 things. Now you're going to be fighting with Docker the whole way, have to plug in like 19 commands into here, pull in all your dependencies. If we're doing it from the get-go, as we add something new, we just make sure it's in the Docker file and it runs. You'll never have to worry about deployment. You already got an image that runs. Every class, every cohort, we get to the end of the individual project, the group project, any projects we do, and it's like the night before they're due, and everyone's like, I can't get it, I can't deploy it, I can't get into an image. It's like, when's the last time you got the image to build? Like, oh, I did it at the end. I've never done it. It's like, well, just keep going. Just do it from the beginning. This is a way to do that. It's replicatable. These are ephemeral. They don't live for long. You kill them, they're dead for good. And this shows exactly what it's going to run like somewhere else. If you don't see the benefit in that at this point, that is okay. I'm telling you, if I have any of your trust, this is very, very useful. This is going to make you significantly better at delivering code than some old crackerjack, brand new junior developer, come through stinking college and all they learned was Python 2 and MATLAB. Like being able to do some of this stuff, you have deliverables that work. This getting into the realm of DevOps, but I honestly think a little DevOps goes a long way for everybody. Any final questions about what's going on here? We're not doing anything crazy. However, this is all new stuff, and do not feel bad if any part of this, you need to ask a question on, because these are not complicated concepts, but they are new concepts, and it's solving a problem you didn't know you had before today.
So to get Docker working, we have to make a Docker Hub account, correct?
Mm-hmm.
And then we have to download Docker onto our OS.
Yes,
Okay. So I got to figure that out for Linux. Ubuntu,
I can
anyways.
help. I can help you with that. We'll get you all squared away. We'll get everyone squared away. Any
Guess I-
questions
Are we-
about? Oh, go ahead.
Are we going to need this for the assessment today?
No, 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 no. God, no. I mean, if you do turn in your assessment Dockerized, I'm gonna be so impressed, but all right.